Okay, so given the particle moves in simple harmonic motion with a maximum velocity of 4 meters per second and a maximum acceleration of 12 meters per second squared. Okay, so the maximum velocity is NA, which equals 4, and the maximum acceleration, now, we could put, I'm using positive NA because it's positive 4, and I'm going to use positive N squared A because it's positive 12 meters per second squared. So if I look at both of these, I get number 2 on number 1, I get N squared A on NA, is 12 on 4, so I end up with N equals 3. That means my period would be 2 pi on 3, or 2 pi on N. Now to get my amplitude, I know that NA equals 4, so I can put the 3 in place of the N and put the A equals 4, so my amplitude would be 4 over 3. So amplitude is 4 over 3. Now a particle moves in simple harmonic motion with a period of pi on 2 seconds and a maximum velocity of 8. Find the amplitude. Okay, so the period is pi on 2. So that means that 2 pi on N equals pi on 2. The pi's will go out. When you cross over, you get 4 equals N, because 2 times 2 is 4, and this times N is just N. And then NA equals 8, so that means 4A equals 8. So if you divide both sides by 4, A equals 2, so that means your amplitude is 2. Okay, so a particle moves in simple harmonic motion, has a period of 6, so that means 2 pi on N equals 6, and an amplitude of 5, which is a possible velocity graph. So firstly, with the velocity graph, that means you differentiated something to get that. So you've differentiated like A, what? It would have to be sine NT. Okay, now if we're looking at this here, let's just look, 2 pi equals, so it's 6 on 1, 6n, divide by 6, and n would be pi over 3, because they cancel. Okay, so that first of all means it could be A or it could be B. The amplitude is 5. Okay, so that's telling me that it was a sine curve with a 5 there, and the n would have had to be pi on 3, so it's pi on 3. So when you differentiate to get the velocity, it's 5 times pi on 3. Sine will go to cos pi on 3t. So that means that the solution would be this one at A. Number 4, okay, so a particle moves in simple harmonic motion with this velocity, v squared equals n squared. 2kx minus x squared, where n and k are constants. X is equal to k, that's initially where the particle is at. Which function in terms of time t could represent the motion of the particle? So you have v squared equals n squared 2kx minus x squared. So because this has an x there, that means that it's going to model this one. V squared is n squared, a squared minus x minus c squared. Okay, so in order to get that into that form, the first thing you'd need to do is to make the minus n squared come first. So it's minus x squared comes first, plus 2kx. And then because it's a squared minus x squared, let's take the minus out and you get x squared minus 2kx. Alright, so we need to complete the square. So we're going to halve it, square it, and then we're going to add it. Okay, but if I add it here, I need to actually add it here. Because by adding it here, that means that with this minus here and the brackets, it means I'm going to subtract what I add. So it's going to be v squared is n squared times, that's outside the bracket, minus x squared minus 2kx. Halve 2k, you get k, or minus 2k. Square it, you just get k squared. So we're not interested in that minus there because it just squares out anyway. So if I add k squared there, I need to add k squared there, because with this here, it means that the two of them would subtract, so I haven't actually physically changed it. So v squared is n squared, k squared minus x squared minus 2kx plus k squared. That would be x minus k squared. So when I am now comparing this, that's n squared, a squared minus x minus c squared. That means that the amplitude would equal k, because that's what the a squared equals. The period is 2 pi on n, measure n, and the centre, c, is equal to k. So when I'm looking for a graph that actually models, it needs to be up k, so you need to have a plus k at the end. So that could be b or d. The amplitude is k, so that's why we're going for b. And then it's got the nt, which works as well. Moving a straight line, so the measurement of the particle starts when c equals 0, which is 0 there. What is the total distance travelled by the particle as it first returns to the origin? So you might be better off actually sketching this one. This is a sine curve that oscillates between 2 and minus 2, 0, pi, and 2 pi. So we want it when it first returns to the origin. So if you look at this particle here, it starts here, first returns to the origin after pi seconds. So how far has it gone? It's gone up 2, down 2, so it has gone 4 meters. So what is the acceleration of the particle when it is first at rest? So that's where it's first at rest, because that's where v equals 0, and at rest means v equals 0. See, if you get it from the graph, once again, it's a lot easier. So it's when x equals 2. X will be its maximum acceleration. We know that's n squared a. That's the quickest way to get it. So n in this one is 3, so it's 3 squared times a, which is 2. So 2 nines are 18 meters per second squared acceleration. If you did it the traditional way, you would know that this would be x double dot minus n squared x minus c. So it's x double dot equals c minus n squared x. The c is 0, because we know that it's not shifted anyway. So it's minus n squared. Now I'm just going to be careful of the signs here, because I didn't really pick up on that there. That's when x, that should be when x equals a. The acceleration at that point should actually be negative, so it would have been minus 18 meters per square. The acceleration is the concavity, and it's concave down, so it would have been minus. And n is 3, so it's 3 squared times a at that point is 2, so it's minus 18 per second squared. So if you are reading from the graph, just a little lesson there, I think I've just taught you, that I actually fell down on, is that when you're looking at the acceleration, if you're reading from the graph, make sure that you check its sign. So the sign there would have actually been minus 18 meters per second squared, because it is concave down. Okay, so with this one here,